All right, so this says, part 4, we're going to do trig function values of common angles. And this is by using the Pythagorean theorem, find the common trig function values of. Well, I'm actually not going to use Pythagorean theorem for us to talk about it. We're going to talk about your 30, 60, 90 and your 45, 45, 90 triangles. Remember those from geometry? Well, they're back. All right, so when you had a 30, 60, 90, I'm going to write this above here. 30, 60, 90 degree triangle. Remember your sides were in the ratios of x, x square root of 3, and 2x. Kind of sound familiar? No. I'm going to tell you that we're going to let x be some number, and I'm going to pick a 1. So if x is 1, what is x square root of 3? Yeah, 1 square root of 3, or just a square root of 3. And what is 2x? 2 times 1, which is 2. So when I draw this triangle, first I'm going to draw it like it's in standard position. Remember, that means that it's going to start on that positive x-axis there. If I drew it as a graph there, and the angle would be at the vertex. I'm sorry, the vertex would be at the origin. So if this is 30 degrees, this means, from what I'm looking at above, the side across from 30 degrees is going to be a 1. That means this top angle here has to be my 60 degree. Across from 60 degrees is going to be the square root of 3. And obviously, hopefully you could tell that was my 90, and across from 90 would be a 2. And so if I'm in my first quadrant, which I am here, then I know that square root of 3 is my x, square root of 1 is my y, and r would be the radius then would be that 2. So knowing that, let's go do part 1. Part 1 tells me that t is equal to 30 degrees, which is equal to pi over 6. So we could write this as, when we go to do our trig functions, we could say sine of 30 degrees, which is the same thing as sine of pi over 6, isn't it? So it doesn't matter if we do it in degrees or radians, it's the same exact angle. What is sine in terms of x, y, and r again?
Your y is over your r.
Yeah, y over r. Guys, I need to make sure you're trying to memorize that, okay? Think what it is, and then look it up to make sure that's what it is, okay? So that you know you've got it. So looking at that triangle I just drew up there, what is my y? 1. And what is my r?
2.
Then we can do cosine of 30 degrees, which is the same as cosine of pi over 6. Which, what is cosine in terms of x, y, and r? X over r. What is x?
Square root of 3.
Over what is r? And tangent of 30 degrees, which we could have said is tangent of pi over 6. And what is tangent in terms of x, y, and r? So what is y? Over what's x? Ooh, but can we have a radical on the bottom of a fraction? No, so how do we get rid of it? Do you remember?
Raise it to
You multiply it by itself. So if I multiply the bottom of my fraction by the square root of 3, what I got to do to the top? Same thing, multiply by the square root of 3. Because really the square root of 3 over itself is equal to 1, isn't it? So I'm not changing the value because I'm multiplying by 1. I'm just changing the way it's written. So on top I have 1 times the square root of 3, which is square root of 3, over, what's the square root of 3 times the square root of 3? Square root of 9, which is 3. So what it makes happen is basically your radical moves to the top, and the number that's under the radical is going to end up on bottom. Just as a little shortcut. All right, we're just going to do, because it said the common trig function values, we're just going to do those main 3, because I think if you've got them, then you can do the reciprocals of them. All right. So while we're on 30, 60, 90, I'm actually going to jump over and do 60 degrees. So I'm going to redraw this triangle right now. I'm I'm using the same angles, 30, 60, 90, still going to be in our standard position, but now I'm going to put 60 degrees down here as that central angle, which means 30 degrees would be up here at the top. So we know across from the 30 degrees, the side is 1. Across from the 60 degrees, the side is the square root of 3. And across from the 90, the side is 2. So that means 1 is going to be my x, square root of 3 is now my y, and 2 is still my r. They switch places because we switched our angles, but we're still in, we got to put them in standard position to be able to say that this is x and this is y. So now let's go through and we're going to do part 3 next. Okay, I'm doing part 3. So we're looking for the common trig function values of 60 degrees. So I'm going to write sine of 60 degrees, but we know that's the same as sine of pi over 3 then, okay? So I'm not going to rewrite that. So sine of 60 degrees, what is that in terms of x, y, and r? What is y? And what is r? Okay, cosine of 60 degrees, which is the same as cosine of pi over 3. What is cosine again in terms of x, y, and r? What is x? And what is r? Good. And then tangent is 60 degrees. What is tangent in terms of x, y, and r? What is y? Over what is x? And what is, we can reduce that, so what does that give us? Yeah, square root of 3. Any questions so far? We still got part 2 to do. We're not skipping it. I just did the 30 and then I went and did the 60 because they're from the same triangle. But so let's talk about 45, 45, 90 triangles. The ratios of their sides were x, x, and x square root of 2. Well, again, let's let x be a 1. So that means across from the 45 is going to be a 1. Across from the 45 is going to be a 1. Remember, if the angles are equal, the sides across from them are also equal, right? And then, so what is the side across from the 90 going to be? Yeah, it's 1 square root of 2, so we can just write it's a square root of 2. So if I draw this in standard position, here's going to be 45 degrees. This is 45 degrees, and hopefully that's obvious. That's 90. So we said across from the 45s, our sides were 1s. And across from the 90, our side is a square root of 2. Because we're in standard position, we can say this is x. We can say this is y. And since this is the hypotenuse, it's my r. All right, so for part 2, it wants us to find the common trig function values of 45 degrees, which is the same as pi over 4. So sine, I'm going to write this one just as pi over 4. Why? Because I can. It's the same exact thing as if we wrote sine of 45 degrees, right? So sine is what in terms of x, y, and r? What is y? Over what is r? Uh-oh, how do we get the radical off the bottom? Multiply top and bottom by the radical. And so on top, 1 times square root of 2 is square root of 2 over square root of 4, which is just 2 on bottom. Cosine of 45 degrees, or pi over 4. What is cosine in terms of x, y, and r? Okay, what is x? Over what is r? Well, wait, didn't we just have that above? So we already know what it's equal to. What's it equal to? Square root of 2 over 2. So I just kind of cheated. I looked above, and then I pulled the answer out. And then tangent of pi over 4, or 45 degrees. What is tangent in terms of x, y, and r? So what is y? Over what is x? Which is? All right, so there's my three main angles besides the quadrantal angles that we're going to be using all throughout our circle. So we're going to use these in all four of the quadrants. Now, remember, we're going to pull this out of this here. So remember, we said what was sine in terms of x, y, and r? Y over r. And if we're on our unit circle, what is r? It's a radius, but what number is it? It's 1. So what we can do is we can look at like part 1 here for 30 degrees. And we can say, okay, for 30 degrees, I have an ordered pair. My ordered pair is going to be an x and a y, correct? Now, we talked about, you just told me that on my unit circle, r is 1. And so which of those trig functions had an x and an r in it? Sine, cosine, or tangent? Cosine. So if cosine of 30 degrees is this, then because if it's on my unit circle, I could say, well, what if I let this be x and this be r? Then that tells me x is my square root of 3 over 2. So I can use that as the x value of my ordered pair. And so what do you think my y value is going to be?
1.
Not 1. Now, on my triangle, it is 1. On my unit circle, though, we're going to use this value that we had. Sine included the y and the r, right? So we're going to say, let's let this be y. And if it is, we know then anything is over 1, isn't it? Whatever number I pick, if I say that y is that 1/2, and we need to make that into a fraction, we would put it over 1, wouldn't we? Like if I said I had the number 2 and I wanted it a fraction, what would you put it over? 1, right? To make it a fraction. So since r is 1, we can say that that 1/2 is over 1, meaning that 1/2 must be my y value. And so 30 degrees is going to have an ordered pair of the square root of 3 over 2, comma 1/2. So what is my ordered pair then for 60 degrees? What is its x and y? What is?
X would be 1 over 2.
Uh-huh.
And then it's y is square root of 3 over 2.
Good, because you're pulling this from sine and cosine, right? And then what about the pi over 4 or the 45 degrees? What would its ordered pair be?
It'd be square root of 2 over 2 for both.
Right. And this stems back, if you think about it, we talked very briefly, and then I changed it to where we used x, y, and r instead of just x and y. There was a thing that told us that if we're on our unit circle, that sine is our y value, and cosine was our x value. And so that's how we're able to look at this also and say, okay, well, if sine is my y, then on like the last one, 45 degrees, then y is sine, then sine was pi over 2, so y is, I'm not pi over 2, square root of 2 over 2. So my y value must be my square root of 2 over 2. Cosine is my x. Well, the cosine here was the square root of 2 over 2 for 45 degrees. So is my x value. And be able to pull that ordered pair from it.